Hey everyone, Mr. Evans here with your pre-recorded live lesson for Unit 6, Lesson 9, The Effects of Change. Now, we mentioned in a couple of previous lessons the concept of mass extinction. And according to our current geological and paleontological evidence, there have been 6 major mass extinctions over the course of planet Earth's history. And while mass extinctions are very bad for the life forms that are there during the event, these mass extinctions events have been the times in Earth's history where the most massive changes in terms of what life looks like have taken place. Because, think about it, we've mentioned that an organism has to be adapted to their environment in order to be successful. And if you have long spans of time where there is not very much environmental change, where things are relatively stable, you are going to get organisms that are very well adapted to that precise environment because they have had no pressure to adapt. If everything's cool and the environment is stable, then the only thing to do in terms of survival of the fittest is to get better at living in that specific environment. But what happens when that environment changes very quickly? If an organism is adapted, specialized, just like awesome in that environment, that means they're dependent on that environment. And they are not good at dealing with changes. So if the environment changes too fast, that organism that was awesome for that environment on Monday could be in big trouble and on its way to extinction by Thursday if the environment changes radically enough. Now, think of other organisms that live in that environment that are, they have, certain niches that they have filled, but they're not the ones like at the top of the food chain in that environment. They have to run, they have to hide, they have to be more resourceful, they have to blend in. Maybe when the dominant life form on the planet goes extinct or starts to have trouble, that provides a window for the other life forms to creep out, to start filling in new areas, new environments, and to start their own paths of evolutionary change. The big one that is closest to us and that we're all probably the most familiar with is the dinosaurs. Dinosaurs, the big dinosaurs like T-Rex, Brontosaurus, Brachiosaurus, Velociraptor, all those ones that we've heard about. First of all, those dinosaurs all lived at very different times. Some of them were millions of years apart, but that's beside the point. Dinosaurs, the big ones, they went extinct around 65 million years ago, and you probably have all heard that it was because of a giant asteroid impact that hit somewhere near the Gulf of Mexico, like off the Yucatan Peninsula. That rapidly changed the environment of planet Earth. And all these big dinosaurs that were huge and fast and tough and had sharp teeth and were really good at living in a warm tropical environment with a lot of food, they had a problem right then at that moment because they were very well adapted to living in that environment. They needed a lot of food to sustain themselves, which wasn't a problem at the time because there was plenty of food. So they just got bigger and stronger and faster and huger and more fierce and smarter and all this stuff. But then all of a sudden, boom, asteroid hits, the environment completely rapidly changes. Dust gets thrown up into the atmosphere, the sun gets blocked out for years, the light source is dim, the plants all die, which means the plant-eating dinosaurs die, which means the meat-eating dinosaurs die, all the big ones. But imagine if there were organisms that could endure this. The smaller dinosaur creatures, type critters that, weren't huge, They were able to scavenge. They were able to find food sources. They didn't need the huge amounts of food and nutrition that the big ones did. They were able to stay around, and they started to adapt to the new environment. It was a little colder, so they started to adapt and change over the eons, down the generations, to have like this downy substance that eventually turned into feathers. They learned how to crawl up into the trees and start to glide. These are changes that happen over many, many years. So the smaller dinosaurs, the ones that could scurry around and survive the mass extinction event, those have evolved into modern day birds. And you can tell if you look at their skeletons. I mean, look at an ostrich and compare it to some of the upright walking dinosaur fossils that we found. If you look at their skeletons, they're very, very similar. It's not a large stretch to say that some of these smaller dinosaurs evolved into upright walking birds like ostriches and emus and things like that. Some of the smaller ones, still the ones that went up into the treetops, they have these, their little front arms, like little T-Rex arms. They were using those to grasp and stuff, but when they got up into the trees, some of them could have evolved webbing between their arms, and they could glide from tree to tree, kind of like a sugar glider squirrel. And over long spans of time, they developed a lighter bone structure, a higher metabolism to flap wings. The feathers grew and evolved, and they became birds of flight. If you look at the skeletons from the fossils, dinosaurs, these little dinosaur skeletons, and modern birds, they are incredibly similar. The big thing is called an inverted pelvic bone, where the inverted pelvic bone allows the wings to attach and flap. Little dinosaurs, they have those. Modern birds, they have those. That is fossil evidence showing similar traits and adaptation. But the one that's most relevant to us is what happened with mammals after the extinction event. Mammals during the time of the dinosaurs were these little rodent-like critters. They lived underground. They were like little moles, little rats, little critters that did have prehensile arms, which means they could grasp stuff, kind of like squirrels do when squirrels are finding nuts and hiding nuts. So they did have that ability, but they were nocturnal. They had to hide underground because the dinosaurs would get them. The dinosaurs were hunting them in their environment. The dinosaurs were eating up all the plants. They would get stepped on by brontosauruses. It just wasn't a safe place for them. So they had to live underground. They had to be nocturnal. But after the extinction event, they peeked out of their little hidey holes, and the dinosaurs, the big ones at least, weren't there. So what happens? They're like, cool, dinosaurs aren't around anymore. I can come out of my hidey hole. I can start expanding my territory. I have new food sources. I don't have to be afraid of being eaten so much anymore. When that happens, their environment has changed, but for the better for them. They have environments that are accessible to them that were not accessible before. And over many long eons, their little prehensile arms became better at grasping things. They could climb trees. They could move around into different areas. And they adapted to, over a long time, become all kinds of different mammals that we see today, including primates. Some of them went up in the trees, started grabbing onto branches, finding fruit and nuts and stuff to eat up in the trees, and it was off to the races after that. So I just wanted to give you like a primer on some of the main things that happen when these mass extinction events happen. And what I just told you is just the example of the most recent one. That's happened 6 times as far as we know. Could have happened more, and every mass extinction event was different, had a different cause and different effects. But there have been 6 that we know of according to our evidence. Could be more. Okay, I'm going to show you a video now from PBS that shows a little bit more detail the journey of what happened to mammals after the asteroid impact that killed off the dinosaurs. And it's really cool. It kind of walks you through not just how we got to humans, but how we got to a bunch of other types of mammals over the course of the past 65 million years. So your multiple choice question will be at the end of the PBS video. It's a really cool video, and I do encourage you to watch it. It kind of fills in a lot of blanks and puts it into a little bit more context. So at the end of the video will be your multiple choice question. So enjoy, and thank you all for coming today.
Over the past several months, we've taken you on a journey through geologic history, one era at a time. If you haven't been on that trip with us yet, those videos, they're all down in a playlist below. And by now, you're probably tired of hearing us tell you that you're related to all of these bizarre organisms that look nothing like you. Like in the Mesozoic era, we introduced you to the Megazostrodon, a little insectivore that lived among the dinosaurs as one of the earliest known mammals. At least that's a mammal, so you can see the connection, right? But what about Dimetrodon? It lived in the era before the Mesozoic, in the Paleozoic. It's not our direct ancestor, but it was a stem mammal, part of the group of animals that descended from reptiles to give rise to mammals. And when you look at it, well, it's not exactly like looking in a mirror, is it? By the time we follow our lineage back even farther to Lyca, the ancestor of all eukaryotes, and Luca, the single-celled ancestor of everything that's alive today, we're talking about forms of life whose lives and structures we can only speculate about. But now you have arrived at the Cenozoic era, and in fact, you've always been there, because that's the era that we're in now. And the Cenozoic is when many organisms took shapes and behaviors that you can actually recognize. Most of the mammals and birds that you can think of appeared during this era, and reptiles went through some surprising changes, but they eventually settled into the ranges that they inhabit today. But perhaps more importantly, for us at least, the Cenozoic marks the rise of organisms that look a lot like you and me. Okay, to be fair, if you had traveled back to the start of the Cenozoic era 66 million years ago, there would still be a lot that you would not recognize. It was so warm that the whole world was full of tropical and subtropical forests, even at the poles. And for about the first 10 million years of the Cenozoic, the world was still recovering from the KPG extinction event that wiped out the non-avian dinosaurs. That was the very beginning of the Paleogene period, and the world was kinda empty. Along with the dinosaurs, almost all other large land vertebrates had vanished. Many terrestrial plants were gone too, and in the oceans, the giant marine reptiles and even most of the plankton had disappeared. Because of this scarcity of life, during this first chapter of this period, known as the Paleocene epoch, there were plenty of open ecological niches, and the surviving forms of life began to fill them. The last remaining dinosaurs, birds, had begun to diversify into some pretty familiar forms. For example, around this time we begin to see the likes of Waimanu, a small flightless water bird from New Zealand that's one of the earliest known penguins. Likewise, in New Mexico, the appearance of Sidiyazi tells us that the ancestors of mouse birds found today all over sub-Saharan Africa were already on the scene. Meanwhile, on the forest floor, some early ungulate-like mammals began to take over. At first, these mammals had it pretty easy because there weren't many predators, but plenty of insectivorous mammals had survived the extinction, and it didn't take long for some of them to start developing a taste for bigger prey. These were the creodonts, predators that first appeared in North America, like the small dog-like Galesion, as well as Oxyana, which looked more like a cat. For a long time, scientists thought that these small meat-eaters were the direct ancestors of today's modern carnivores, but in recent years we've learned that they actually are a separate lineage, one that only happened to converge on the same strategies and overall body plans of the carnivores we know today. Now, other mammals made their homes in the trees, including some of the first primate-like species, the Plesiadapiforms. They first showed up in Europe and North America, and even though most researchers think they weren't direct ancestors of primates, they can still tell us a lot about what the earliest primates might have looked like. Purgatorius, for example, looks a lot like a rat, but it had long, grasping fingers useful for life in the trees, and wide teeth for chewing things like fruits and leaves. But like other Plesiadapiforms, Purgatorius had claws instead of nails, and it was missing one of the key features of a true primate. Its eyes didn't face forward. So by the middle of the Paleocene epoch, animal life was on the rebound. And then it started to get really warm. Around 55 million years ago, the average temperature on land went up by 5 to 8 degrees Celsius in less than 20,000 years. This spate of global warming marks the transition to the next epoch, the Eocene, and it's known as the Paleocene-Eocene Thermal Maximum, or PETM. Remember this one. If you've seen our episode on this phenomenon already, already, then you know that we're not totally sure what caused it. It might have had to do with volcanic eruptions or melting methane ice on the ocean floor that released greenhouse gases into the atmosphere. Either way, as a result, a world that was already warmer than today's world started to get even hotter. At the poles, lush ecosystems took hold while parts of western North America became arid. This was great for animals that thrived in the heat, like reptiles. How great? Well, this is when the world saw the biggest snake that ever lived. Titanoboa slithered through southern America during this hot spell, all 13 meters of it, about twice the size of a modern anaconda. It feasted on fish, but also crocodiles and also anything else it could get its jaws around, which was most things. Also in the water were reptiles like the giant turtle Carbonemes, which, unlike our shelled friends that we know and love today, were about 3 meters long and fed on mammals and other reptiles. While all this was going on, some of the first true primates were appearing. The tiny Omamaids, for example, had grasping fingers with nails instead of claws and giant eyes like tarsiers. Then, about 49 million years ago, this warming trend shifted and the world began its long journey from a greenhouse to an ice house. This shift may have been caused, at least in part, by what's known as the Azola event, where massive amounts of this small moss-like Azola fern grew in the Arctic. These plants took up half of the carbon dioxide in the atmosphere, enough that the climate began to cool, and a lot of mammals from the Paleocene couldn't handle the cooler, drier weather of the late Eocene, so by about 40 million years ago, many of them had gone extinct. At least 45 groups disappeared from Asia, like the Eurymylids, a family thought to be closely related to early rodents. In North America and Europe, the changing forests caused problems for mammals that lived in the trees, including primates. By the late Eocene, practically all of the primates on those continents died out. But at the same time, some modern mammal groups start to show up in the fossil record, like familiar rodents and the odd-toed ungulates, the group that includes today's horses, rhinos, and tapirs. And it's in the late Eocene that some of the simians, the clade that includes monkeys and apes, began to appear in the fossil record. By the time the next epoch, the Oligocene, begins around 34 million years ago, we start to see the likes of Egyptopithecus in northern Africa, an early member of the group that includes what are known as the Old World monkeys and eventually the apes. But now the global temperature was taking an even steeper plunge, with ice sheets beginning to form in Antarctica. And soon, another extinction event began, this one mostly in Europe. It's known as the Grande Coupure, and like most other extinctions, we haven't figured out all the details of what caused it. But we know the drop in temperature would have made it hard for some of the older groups of mammals to survive. It might have also lowered sea levels enough to allow more migration from Asia and therefore more competition. Almost all of the tree-dwelling European mammals were wiped out, and all kinds of new creatures moved in, like true carnivores and artiodactyls, the group of ungulates that included animals like today's pigs, deer, and cattle. Then, in the cooler, drier climate of the Oligocene, a new habitat appeared: grassland. And this was an enormous deal because the fibrous grass was harder to digest than the softer vegetation like leaves, which meant that animals had to adapt or die. Among the herbivores, the even-toed ungulates known as ruminants had the advantage because they had an extra stomach chamber where grass could be fermented and partly digested, then sent back to the mouth to be chewed again. In the late Oligocene, there was also a major split among the simians. Around 26 million years ago, the first so-called New World monkeys appear in the fossil record in South America. We're not really sure how they got there, although the lower sea levels might have helped them get around. These New World monkeys retained a lot of the traits of earlier monkeys, like their small size and fruit-based diet. Meanwhile, the larger Old World monkeys in Africa and Asia began to take a different route. Many of these Old World monkeys had a broader diet, and some started to spend more of their lives on the ground. Now, the transition from the Paleogene to the next period of the Cenozoic, the Neogene, is a subtle one, usually recognized by changes in microscopic fossils of things like algae and foraminifera. But the events that unfolded during this period, starting 23 million years ago, were hard to miss. The Neogene opened with the Miocene epoch, as continental plates were on the move, kicking off an era of mountain building that continues today. The Himalayas were forming as the Indian plate rammed into Asia, while collisions in Europe started to create the Pyrenees and the Alps. Meanwhile, in Africa, another transition was underway as the first apes evolved from the Old World monkeys. We're not completely sure what the first ape was, but a transitional genus called Proconsul first appeared around the start of the Neogene that may have been close to the start of the ape lineage. The most obvious trait of these animals was their lack of a tail, but they also had more flexible shoulder joints, broad, flat rib cages, and a shorter spine. Among other things, these traits combined to make it easier for apes to swing from the trees and eventually to balance on two legs. For the most part, the rest of the Miocene continued the trends that began in the Oligocene. As the world continued to cool, forests began to shrink while grasslands spread. For animals that grazed, instead of browsing on trees, they had vast new expanses to disperse to. But almost all of the herbivores that couldn't survive on grass, like browsing horses, began to disappear. In the oceans, the bizarre marine mammals like Desmostylia had disappeared, but new forms of life started showing up in the fossil record, like sea otters and other animals that made their homes in the world's first kelp forests. And in the meantime, apes continued to diversify. In the next few million years, the ancestors of each of the great apes split off from the ancestors of humans. The ancestors of orangutans diverged from our lineage about 13 million years ago. The ancestors of gorillas were next around 10 million years ago, followed by the ancestors of chimpanzees and bonobos around 7 million years ago. By the time the Miocene ended 5.33 million years ago, the lineage that would lead to humans was established. In fact, most of the groups of animals around the world today had evolved. The world was getting closer to something we would truly recognize. Sure, there was the occasional Gomphothere or three-toed horse, but other groups like canids, bears, and whales were fully fledged. The transition to the next epoch, the Pliocene, involved a brief period of warming, followed by an even faster drop in temperature. South America, which had detached from Antarctica in the Oligocene, finally bumped into North America, cutting off the Atlantic Ocean from the warm currents circling the equator. And as the climate continued to cool, our ancestors, the hominins, were taking over the expanding grasslands. The first known hominins, Australopithecus, appear in the fossil record around 4 million years ago. Researchers think some of these early hominins were actually able to digest grass, which would have made it easier for them to find food no matter what the climate was. Over time, they became better runners and more skilled hunters. And there's evidence that toward the end of the Pliocene, they had begun using stone tools. By 2.8 million years ago, just a couple 100,000 years before the end of the epoch, a new genus, Homo, appeared on the scene in the form of a lower mandible found in Ethiopia known as the Ledai jaw. The end of the Pliocene also marked the end of the Neogene and the start of our current period of the Cenozoic, the Quaternary, about 2.5 million years ago. And this most recent chapter in the history of life is so packed with crucial developments, from the last ice age to the rise or the spread of Homo sapiens, that we will handle them all in a separate episode. But by now you've seen how the events of the Cenozoic truly shaped our world and us. It began with the world recovering from extinction with millions of niches for mammals to fill, and it peaked with a warming event that helped spur the rise of the primates. Yes, you might not be the spitting image of Egyptopithecus, but the Cenozoic era was when the world as we know it came to be. More than any other era in history, it is our time. Thanks for watching me today. Now, what do you want to know about the story of life on Earth? Let us know in the comments, and don't forget to go to youtube.com/eons to subscribe. As part of us trying to give you things with which to support this show, Eons has developed a really kind of beautiful piece of art in the form of a poster that is now available at dftba.com. I've got mine. Did you get yours?